Hi students, now we'll be looking at the second part of today's lesson and we'll be looking at the first question of the day. Is how to calculate concentration of solution in a chemical equations using mole ratio. So this will be what we are looking at for this part of the video. So at example 5 on page 5 of your notes, 100 cm cube of dilute hydrochloric acid is added to pieces of magnesium to produce 1.2 dm cube of hydrogen gas. Calculate the concentration of hydrochloric acids. So in this case, right, when you are not given any units for concentration, right, the default units will be mole per dm cube. So in this case, let's do this equation. Okay, so this above reactions, right, is acid plus metal, which you'll be learning in acid and base in chapter 9. So after you learn chapter 9, right, you are supposed to know how to write out the product of this reaction. So this is how I balance the equation. I write out all the magnesium, all the reactants and product first in this order. And I notice that for the right hand side, there is 2 chlorine. But on the left hand side, there's only 1 chlorine. That's why I add in 1 unit of hydrogen chloride, which is your hydrochloric acid, to balance out the equations. So once I add in, I realize that the equation is balanced. So now, how do we do this question? First step, always put down the information that are given. So in this case, we are given 1.2 dm cube of hydrogen gas. And write down what we are trying to find in this question. So we are trying to find out the concentration of hydrochloric acid. So I put a question mark here. So let's do a quick recap. In chapter 8, right, we learned that concentration for mole per dm cube is equals to the number of mole divided by the volume of solution. And we need to know that 1 dm cube equals to 1000 cm cube. And always take a good look whenever you do it volume of solution or volume of gas, right? Make sure that you're in the right units before you do any conversion. So in this case, here is 100 cm cube, and this is what we like to test also, to test whether student understand whether you know how to convert from cm cube to dm cube or not. So in this case, first step, I convert my hydrogen gas to number of mole first, because I know that in 1 mole of any gas, it occupies 24 dm cube. So to find out the number of mole, I take 1.2 dm cube divided by 24 dm cube. And these equations can only works, this formula can only works for volume of gas. Volume of gas. So now, same thing, I need to identify what is the mole ratio of hydrochloric acid is to hydrogen gas. So in this case, it's 2:1. So it means that 1 unit of hydrogen gas is 0.015, and now I need to calculate what is the number of mole for hydrochloric acid, which is 2 units. So in this case, I take 2 times 0.05, give me 0.1 mole. So once I have the number of mole, I can calculate the concentration of hydrochloric acid. But before that, I need to convert this 100 cm cube to dm cube first. So I take 1000 divided by, so I take 100 divided by 1000, which gives me 0.1 dm cube. So in this case, I'll be able to calculate the concentration of hydrochloric acid. So same thing, I need to write down the 3-step statement. First step, calculate the number of mole of hydrogen gas. 1.2 divided by 24, give me 0.05 mole. And the second step will always be to identify the mole ratio. In this case is 2:1 for hydrochloric acid is to hydrogen gas. So number of mole of hydrochloric acid will be 2 times number of mole of hydrogen gas, which is 0.1 mole. And lastly, calculate the concentration of hydrochloric acid in mole per dm cube. So I take the number of mole, 0.1 mole, divided by 0.1 dm cube, which is equals to 1 mole per dm cube. So now the next part, next example 6. So in this question, 100 cm cube of dilute hydrochloric acid reacts completely with 200 cm cube of 0.5 mole per dm cube sodium hydroxide. So calculate the concentration of hydrochloric acids in this question. So this reaction here, right, is actually an acid plus alkaline reaction that you'll be learning in chapter 9 soon. So stay tuned. So first step. So in this question, right, instead of asking you to calculate from like reactants to product or products to reactant, right? Now both of these substance, right, are in the reactants. So first step, I put down the information I have first. So for sodium hydroxide, I have the volume, which is 200 cm cube, and for the concentration, right, is 0.5 mole per dm cube. And what I'm trying to find is the concentration of hydrochloric acid. So let's recall that the concentration in mole per dm cube is equals to the number of mole divided by the volume of solution. So how do I recall this formula, right? I look at the units here and I do the divide accordingly. So it's mole per dm cube, right? That means I take number of mole divided by volume of solution. And recall that 1 dm cube equals to 1000 cm cube because we are given in cm cube for these two questions, for these two substances here. So first step, convert it to mole. So how do I convert it to mole? So I'm given the volume and I'm given the concentration. So when I take volume times concentration, I'll be able to cancel the units dm cube, and I get number of mole. So first thing you have to convert 200 cm cube to dm cube first by dividing by 1000. That's why I get 0.2 here. So 0.5 times 0.2 equals to 0.1 mole. Second step, identify the mole ratio. So in this case, right, is 1:1 ratio. It means that the number of mole of sodium hydroxide that is being reacted is the same as the number of mole of hydrochloric acid in these questions. So my number of mole of hydrochloric acids will be 0.1 mole. And now I can find out the concentration of hydrochloric acid, which is taking the number of mole divided by the volume of the acids used. So in this case, it's 0.1 mole divided by 0.1 dm cube. And this 0.1 here, right, is after I take this 100 cm cube divided by 1000 to convert it to dm cube before I can divide. So 0.1 mole divided by 0.1 dm cube, which gives me 1 dm cube, 1 mole per dm cube as the concentration of hydrochloric acid. Same thing, 3-step statement. First step, calculate the number of mole of sodium hydroxide. In this case, it will be 0.2 times 0.5 equals to 0.1 mole. Next, identify the mole ratio of hydrochloric acid and sodium chloride and sodium hydroxide, which is 1:1. So the number of mole of hydrochloric acid is equals to the number of mole of sodium hydroxide. So in this case, it's 0.1 mole as well. And lastly, calculate the concentration of hydrochloric acid, which is what we want to find in these questions. So I take 0.1 mole divided by 0.1 dm cube. Okay, so if you want, right, you can add a statement here. The volume of hydrochloric acid equals to 100 cm cube. Okay, let me write a statement for you. So volume of HCl equals to 0.1 equals to 100 cm cube divided by 1000 in order for me to convert it to dm cube. Okay, so you can add this statement here so that you will take note that you need to do a conversion. Okay, so this is the last example. So now, question 3, class work. So for this class work, right, I will need you to take about 2 minutes, pause this video, do it yourself first, so that when you try this question again, you'll know like which part you need to take note of and which part you are unaware or like unfamiliar with, and you will be more focused on that part that you don't know how to do. And this is how learning occurs, because you will feel uncomfortable first before you know how to do this question. So this question, okay, so take a pause here, pause. Okay, so no. So after you have finished, you can continue this video. So for this question, question 3, sodium carbonate reacts with dilute hydrochloric acid to give 24 dm cube of carbon dioxide. Calculate the volume of 1.0 mole per dm cube of hydrochloric acid needed in the below reactions. So in this reaction here is an acid plus carbonate reaction that you'll be learning in chapter 9, acid and base. No, chapter 10, acid and base, correct. So this is the chemical equations. So now, step 1, always put down the information that are given in questions. So in this case, we are given 24 dm cube, put it down, and what you want to find. So in this case, you're given the information of the concentration of hydrochloric acid, and you want to find out what is the volume. First step, recall that the volume of solution is equals to the number of mole divided by concentration. Okay, so this working over here is like a math step here. So when you take mole, so whenever we do a divide sign, right, you'll be like swapping the numerator and denominator. So in this case, right, my mole will be in the denominator and dm cube will go on top. So dm cube over mole. So when I take the mole, cancel each other, I'll find out what is the volume. So step 1, calculate the number of mole. So we know that in order to calculate the number of mole from a volume of gas, I take the volume of gas divided by 24 dm cube. So in this case, it's 1 mole. So now, identify what is the mole ratio of hydrochloric acid and carbon dioxide. So in this case, the mole ratio is 2:1. It means that 1 unit of carbon dioxide is equivalent to 1 mole. So now I need to find 2 units. In this case, it will be 2 times 1, 2 mole. So in order to find out what is the volume, I need to take the number of mole divided by the concentration of hydrochloric acid. So in this case, my number of mole is 2 and my concentration is 1 mole per dm cube. So I take 2 divided by 1. So after I cancel out the units, as in after the manipulation of units, then you'll be able to find out what is the volume of the solution of this hydrochloric acid. So 3-step statement. First step, calculate the number of mole of carbon dioxide. In this case, it's 24 divided by 24, give you 1 mole. Next, find out what is the mole ratio. So in this case, 2:1. So the number of mole of hydrochloric acid is equals to 2 times number of mole of carbon dioxide. So in this case, 2 times 1, which is 2 mole. And lastly, find out what's the... Okay, give me a moment. Okay, next, find out what is the volume of hydrochloric solution being used in the experiment. So in this case, I take number of mole divided by the concentration. So it's 2 divided by 1. So I get 2 dm cube. So now, we have come to the end of the first question of the day. So please look at the third part video in order to know how to use the volume ratio in order to calculate the volume of chemical equations that involve all gases. Thank you.